Welcome back, everybody. So today we're going to solve another famous problem called the handshake problem, and then we'll solve a few related problems. So I brought back my math guru Kyle to help me out.
Hey guys.
Kyle, why don't you describe the handshake problem?
9 people are introduced to each other at a party, and each person shakes hands with each of the others exactly once. How many handshakes are exchanged altogether?
So how do you think we should do this one?
Let's just write out numbers for the people.
So they'll be numbered from 1 to 9. And then we'll pretend like they're all outside the room, right?
And then number 1 walks in.
So how many people does person number 1 shake hands with?
Nobody.
He doesn't shake hands with anybody, right? Because there's no one in the room yet. He's the first guy. So we're done with person 1, and we have 0 handshakes. So now, person 2 is going to walk into the room.
And then he shakes hands with person 1.
So at this point, we're done with person 2, and we have 1 handshake. So now, person 3 is going to walk into the room.
And he's going to shake hands with person number 2 and person number 1.
And so person 3 is going to add how many handshakes?
He's going to add 2 handshakes.
And we are done with person 3. So now, person 4 is going to walk into the room.
And shake hands with 3, 2, and 1.
So he's going to add how many handshakes?
3.
And we are done.
With person number 4.
Person 5 is going to walk into the room.
And he shakes hands with person number 4, 3, 2, and 1.
So he's going to add
4 handshakes.
And we are done.
With person number 5.
And so now I think we can start to identify a pattern, right? So the next guy that walks into the room will be person number 6.
So there'll be 5
So
handshakes.
he's going to shake hands with 1 less than what his number is, right? Because there's always 1 less than his number that is already in the room, right? So now person 6 is going to walk into the room, and he's going to shake hands with 5 people. Person 5,
4, 3, 2, and 1.
We'll be done with person 6.
And then we'll move on to person number 6.
So person 7 is going to shake hands with 6 people. Person 8 is going to shake hands with
7, 6, 5, 4, 3, 2, and 1.
So that's 7 people, right? And then person 9, the last person to go into the room, he's going to shake hands with 8 people. So you can see once again, everybody shakes hands that enters the room, shakes hands with 1 less than the number of people that we have. So we see the problem will actually reduce to the sum of the numbers from 1 to 8. And we know how to solve that problem, right?
N times n plus 1 over 2.
Yep, so it'll be 8 times 9 divided by 2. We'll cancel out the 2 and the 8.
And then 4 times 9 is 36.
That's right, 4 times 9 is 36. So we have 36 people, 36 total handshakes for 9 people. So now let's write a formula for this one. So now the formula for the sum of the numbers from 1 to n that we derived earlier is n
times n plus 1 over 2.
N plus 1 over 2. But now we want to use n for the number of people that are shaking hands, right?
And we know that the number of handshakes that are made is made with 1 less than how many people are in the room.
That's right. So it'll be the sum of the numbers from 1 less than the number of people that are shaking hands, right? So we're going to replace n with n minus 1 And then we take the next integer higher than n, so that'll be n divided by 2. So if n people are shaking hands, the total number of handshakes will be given by n minus 1 times n over 2. So this is very important because we got the sum of the numbers just like we learned earlier with Gauss's trick, but the key is if there's n people shaking hands, it's the sum of the numbers from 1 to n minus 1. So for this given problem, we wouldn't want to calculate the sum of the numbers from 1 to 9 for how many handshakes that took place. That would be wrong. So it's always n minus 1 times n over 2, but you can simply think of it as for n people shaking hands, we're taking the sum of the numbers from 1 to n minus 1. And that is the handshake problem.
I have a joke for you.
All right, another joke? Let's hear it.
What's worse than being bit by Dracula?
I don't know. What is worse than being bit by Dracula?
Shaking hands with Captain Hook.
That's a good one. I like that. Looks like that would be mighty painful, wouldn't it? Okay, so there's our first problem. Let's move on to our next problem. So for our next problem, go ahead and tell us about it, Kyle.
Each person in a certain group shake hands with each of the others exactly once, and 120 handshakes are exchanged altogether. How many people are in this group?
Okay, so this is kind of like the reverse problem to the one that we just got done doing, right? It's handshakes, but this time they're giving us the total number of handshakes, and we have to figure out how many people are in the group. So how should we proceed?
We should write out the formula and say that equals 120.
All right, so we write out the formula that we had for the number of handshakes.
Which is n minus 1 times n over 2, and that equals 120.
Okay, so in this case, the total number of people will be given by n, right? Because we'll have the sum of the numbers 1 less than the total number of people, right? So when we solve for n, then that'll actually be how many people are in the group. All right, so what do you want to do now?
Now, we're going to multiply by 2 to clear fractions.
All right, you're going to clear out those fractions, huh? You're not much of a fraction guy?
No.
Okay, so now what we're looking for is we're looking for two consecutive integers that multiply together to be 240. Now, multiplying consecutive integers is kind of a pain, but we can kind of get a good estimate and get in the right range by just taking squares, right?
Exactly.
And then we can just add another of the same number that we're taking the square to get the next consecutive integer, right? So let's start off. How about 11 squared?
That's 121.
Yeah, 11 squared is 121, so if I add another 11 to that, I would get 11 times 12, and that would be 132. That's not very close, is it?
So we need something that's pretty close to 240.
Yeah, so we need something bigger than that.
Let's try 15 squared.
Yeah, let's try 15 squared because we can get that one easy using our square ending in 5 trick, right? So if we take 15 squared, we know it's going to end in 25.
And the next integer higher than 1 is 2.
Yeah, so the number in the tens place, not counting the number in the ones place, right, is a 1. And so we'll take 1 times the next highest integer from 1, which is 2. So 1 times 2 is 2, and we get
225. Now that's pretty close to 240.
That is very close.
So all we have to do is add another 15.
Yeah, so if we want to get consecutive integers, and we'll take 15 times 16, and that's actually equal to 15 times 15 plus 15 times 1 using distributive, right? And so that'll be 225 plus 15 is exactly 240. So that's what we were looking for. So n, in this case, the n minus 1 is going to be 15, and n will be 16. N is what we're looking for, right?
So that'll mean we have 16 people in the group.
Yep, so there's 16 people shaking hands, and that'll give us a total number of handshakes of 120. So now on to our next problem. Go ahead, Kyle. Tell us about this one.
25 chess players hold a tournament in which each player plays just one game with each of the other players. How many games are played altogether?
So how should we handle this one?
Well, it's technically just like the handshake problem, except instead of people, it's games.
Yeah, so it's basically exactly the same as the handshake problem, but instead of shaking hands, we're just going to play the games like you said.
And I like chess.
You really like chess, right?
Yeah.
All right, so if we got 25 people playing games and everybody plays one game against each of the other players, then that means the total number of games that'll be played is the sum of the numbers from 1 to 24, right? One less than the total number of people we have playing games. And that is going to be
the sum of numbers from 1 to 24.
24 times 25 divided by 2. Okay, so I can cancel out the 24 with the 2, and now I'll have 25 times 12. So 25 times 12, I'll actually write that as 25 times 10 plus 2, and I'll use distributive to get 25 times 10 plus 25 times 2. 25 times 10 is 250. 25 times 2 is 50. So I get a total of
300.
300 games.
That's a lot of games.
That is a lot of games. Okay, so for our next problem, we've got how many different line segments can be named in the figure below. So we're going to count AB and BA as the same line segment. So let's start with A. So we can write segments considering A, we can write AB, AC,
AD, and AE. Now, A can't be used anymore because at the same time, count AB and BA as the same line segment.
That's right. So now we're done with point A. So now let's move on to point B. So we can write line segments
BC,
BC,
BD, and BE.
That's right. So when we get to B, we're done with B now. We're only going to go forward now, right? We're not going to look back at point A because that would be BA, and we already have that when we considered AB, right? So when we get to a given point, we only look at the points above it in order to make new line segments. So now we're moving on to point C. So we've got CD and CE. And we're done with point C. Okay, so finally we're going to move on to point D.
And we can only go to point E since all the others have already gotten to point D.
That's right, so we'll add one more additional line segment, and that'll be DE, and we're done with D, and we're done with E, because we can only look forward, and once we get to E, there's nobody in front of it, so that means that we're done. So now let's look at what we've got. So we're going to add up all these different line segments. So we've got 4 from point A,
3 from
3
point
from
B,
point B.
2 from point C, and 1 from point D.
That's right, so that's the sum of the numbers
From 1 to 4.
from 1 to 4. And we can see that that's just handshake again, right?
Mm-hmm.
So we've got 5 points. We're making how many line segments are we making out of that point? It's just the sum of the numbers from 1 to 1 less than the number of points we have, or in this case, the sum of the numbers from 1 to 4, and that is 10. So we have 10 unique line segments, but once again, this is a problem that just straight reduces to the handshake problem. Okay, and so we come to our last problem. Go ahead and read this one for us, Kyle.
The figure below is a 10-sided polygon, which is called decagon. How many diagonals can be drawn in it?
Okay, so we want to look at how many diagonals we can draw.
If you don't know what a diagonal is, it's a line that's not one of the sides, connecting from one point to another point.
Yep, so let's start off with point A, and we'll just start making diagonals from one point to the other point. So there's nothing from A to B, that's not a diagonal, right? So the first one that we can make is AC. The next one will be AD, AE, AF, AG, AH, and AI. And that is a total of 7 diagonals for point A. So now we move on to point B,
which can be gone to point C.
Nope, not point C, because that'll be one of the sides, right? So the first segment that we can make is from B to D,
then B to E, then B to F, then B to G, then B to H, then B to I, then B to J. That's all you can do with the B's.
So in this case, we also have 7 diagonals that we can make. So now let's move on to point C. So we can go from C to E,
C to F, C to G, C to H, C to I, C to J.
so that'll be a total of 6 diagonals for point C. And you might ask, well, why didn't we make a diagonal from C to A?
Because that's already been taken.
That's right, we already made that diagonal.
They didn't mention this in the problem, but they count CA and AC as the same.
That's right, CA and AC are exactly the same, so we don't want to duplicate that one. So similar to the previous problem, once we get back to A, then we don't recount those points, right? So we've got to stop at J and not go back to A, because then we'll be double counting diagonals. We don't want to do that. Okay, so now let's move on to point D. We can go from D to F, D to G, D to H, D to I, and D to J. So that'll be a total of 5 diagonals for point D. So we'll move on to point E. We can go from E to G, E to H, E to I, and E to J. So that'll be a total of 4 diagonals for point E. So we'll move on to point F. So we can go from F to H, F to I, and F to J for a total of 3 from point F. So now I think we can see how this is going to go, right? So we'll get from G, so we can go to G to I and G to J. That'll be 2. And then when we get to H, we can just go from H to J. That'll add 1 more. So let's add these up. We've got 7 plus 7 is 14, plus 6 is 20, plus 5 is 25, plus 4 is 29, plus 3 is 32, plus 2 is 34, plus 1 is 35.
So it'll be 35 diagonals.
Yep, so we got a total of 35 diagonals. But it's not that good because it doesn't really follow our previous handshake formula, right? We got 2 7s there at the start, and then it starts kind of counting down. But, you know, we're not going to be able to handle this type of problem. What if they gave us a 100-sided polygon? We're not going to want to use this approach, right? So it'd be nice if we could relate it to the handshake problem.
We can.
Because then we could just be able to think about it more clearly without having, you know, as the number of sides of the polygon gets very large, we can just relate the simpler problem to the larger problem without having to count all of the diagonals by hand, right?
You can make a formula.
So how should we do that?
Well, let's say we can draw on the line segments and say that AB is a diagonal.
Okay, so we're just going to include all line segments, not just diagonals, right? So if we consider all line segments from one point to another point, then it becomes just like the previous problem that we did, right? Just counting line segments, and we just showed that that reduces to the handshake problem, right? So if we did that, and we have 10-sided polygon with 10 points, how many total line segments that we can draw will just be the sum of the numbers from 1 to 9, right? So that would be 9 times 10
over 2.
Over
you
2.
Can simplify the 10 to 2 to make 9 times 5, which is 45.
Yep. So that would be 45. But when we do it that way, now we've included line segments that are part of the sides, right? Which we didn't want. So how many of those line segments are we going to have that we didn't want?
We're going to have 10.
10 in this case, right? Because we have 10 sides, so 10 of the line segments that we've counted, part of the sides and are not diagonal, so we don't want those. So we'll just subtract them off, and sure enough, that gives us a total of 35 diagonals. So if we have n sides, we can write a formula for this saying n minus 1 times n over 2 minus n, where n will be the number of sides, right? And in that way, we get the n minus 1 times n over 2 because that's just counting the total number of line segments we can make.
We have to subtract the line segments because they're not diagonal.
Yep, we'll subtract the line segments that are not diagonals, which are line segments that make up the sides, and that's just the number of sides that we have, right?
But it says how many line segments can be drawn. You don't have to subtract n.
That's right. So the key point that I want you to take away from these problems is in math, a very important problem-solving strategy is that if we come to a problem that we've never seen before, if we can reduce that problem to something that we already know how to solve,
it should be a piece of cake.
It'll be a piece of cake, and essentially we know how to solve that problem, right? So in the very first video, we learned how to use Gauss's trick to figure out the sum of the numbers from 1 to n, and then we just showed that the handshake problem actually reduces to just the sum of the numbers from 1 to n minus 1 if you have n people shaking hands, right?
Exactly.
And we know how to solve the sum of the numbers from 1 to n minus 1, so that means we know how to solve the handshake problem. But then we also showed that we can reduce how many players play games in a chess tournament to the handshake problem as well, right? So since we know how to solve the handshake problem, because we know how to solve the sum of the numbers from 1 to n minus 1, we know how to solve the number of people playing games in a chess tournament, right? And we also showed that the number of line segments between different points also reduces to the handshake problem, right? And then we've shown that if we're a little bit clever about how we do it, that we can also relate the number of diagonals in a polygon to the handshake problem as well, right? If we subtract off the line segments that are part of the sides. So we see that we can look at 4 or 5 problems that on the surface of it appear to be different, right? But we see that they all come down to summing the numbers from 1 to, say, n minus 1 in this case, for the handshake problem. And so essentially, because we know how to solve the sum of the numbers, we know how to solve all these problems, right? So whenever you run across a problem in math that you're unfamiliar with, see if you
break it down into something you do know how to solve.
See if you can relate it to something that you do know how to solve, or break it up into individual pieces that you know how to solve that you can then put together. And I think you'll find that that'll be a very important and powerful problem-solving strategy for you. And that's it for today, and I hope you guys enjoyed this one, and we will see you again next time.
Make sure you subscribe.